Solve by factoring more. So I want you to recall if m times n is 0, then m is 0 or n is 0. And look, that's two factors, but it could be any number of factors. So the steps to solve by factoring are 1, set the entire thing equal to 0. 2, factor completely, right? We talked about that. That's making sure you don't have any pluses or minuses outside parentheses unless you have a leading negative, like -3 times something. Your power is not bigger than 1 inside parentheses. That just means it may factor. It doesn't guarantee it. And you don't have a GCF still in your parentheses. Then you set each factor equal to 0 for the third step and solve each for your fourth step. So I'm going to follow this color scheme of get it equal to 0 in purple, factor it in red, set each factor equal to 0 in blue, and solve each one of those in green. So I'm going to go ahead and change this to purple so I'll be ready to start. X squared equals negative 11x minus 10. So let's look at this and just see what we can do here. Well, I like to leave my highest power positive. That's positive, so I'm going to add 11x to both sides, and I'm going to add 10 to both sides. I'm just going to write this over here, and then these things are going to cancel and give me equals 0. None of these terms are like. That means you can't combine any of them. So the easiest thing to do is 11x squared plus 11x plus 10. That's called descending order. The reason that's the easiest is because it's easier to factor when it's in descending order, in my opinion, okay? And I'm going to look at this and go, okay, how many terms do I have? So first of all, I'm getting ready to factor. So set it equal to 0 is done. Check. Now I'm going to factor it. So change to my red. So to factor it. Well, 3 terms here, and there's a 1 in the front, and there's no GCF. So this is what we call the list method, or what I call the list method, right? So if you need help factoring this, go back and watch my list method video there. So 3 terms, 1 in the front. So we need the factors of 10, 1 and 10, or 2 and 5, all right? So then I want the factors of 10 that add to give me 11. I'm not worried about plus or minus 11. I'm worried about 11. So 1 plus 10 is 11. So put the 1 and the 10. It doesn't matter what order, okay? So 1 and 10. And then now this says both. They have to be the same sign, the 1 and the 10, or you don't get a plus. And they're both that one. They're both positive, okay? So both positive. Both positive. So now it is factored completely. So then let's go over here and let's do step number 3, which is to set each factor equal to 0. So x plus 1 equals 0, or x plus 10 equals 0. All right. So then that is step 3 factored and done. I'm sorry, not factored, set equal to 0. Factored was the red step. And then step 4 is to solve each one of these. Subtract 1 there, x is negative 1, and then over here subtract 10, and x is negative 10. So x equals negative 1 or negative 10. And step 4 is now done. Step 4 is now done. So 5x squared minus 20x equals 0. First step, is it equal to 0? Sure is. Check. Then we factor it. Well, we have a GCF, we have a power bigger than 1, and we have a plus or minus not in parentheses, so we have all 3 reasons it's not factored. So then it's 2 terms. Is there a GCF? And the answer is yes. 5x is a GCF, and you're left with x minus 4. Then we still have 2 terms in here, but the power is not bigger than 1. Don't force that to be difference of squares there. That's just x minus 4. It just stays you are completely factored. That's in parentheses. There's nothing in here. There's nothing between there, plus or minus. That would separate a term, okay? There's no power bigger than 1 here, and there's no GCF in this. So it's completely factored. So that is step 2. Step 3 is to set each factor equal to 0. So 5x equals 0, or x minus 4 equals 0. So I'm going to divide both sides by 5 here to get x equals 0. And then over here, I'm going to add 4 to both sides. And then that's going to give me x equals 4. So I don't like that 4 there. So then x equals 0, or, wait, I don't know what I got to change this. I'm sorry. I messed my coloring up, right? I'm going to do the same work. That's done. And then we're going to do this. We're going to divide by 5 here. So x equals 0. And then we're going to add 4 here. and x equals 4. So x equals 0 or 4. All right? And now it is solved. I just changed my color. I didn't mess the work up. I just did it in a different color. All right? So let's see. So what about 14x squared minus 19x equals 13x squared minus 48? So what we'll do is get it equal to 0, right? Because it's not equal to 0 now. So right now we got to get it equal to 0. I want my highest power to be positive. So if I look at this, I have a 14x squared on this side and a 13x squared on this side. So I'm going to move the smaller one. I'm going to move it over here. So subtract 13x squared from both sides. And then I'm also going to add 48. So I'm going to write plus 48. It doesn't matter where I write it. I'm just going to write it over here on this side. All right, so these two things cancel and give me equals 0. And on the other side, these two are like terms. If I put that together, 14x squared minus 13x squared is very nice. I'm not going to write it underneath it because if I want to factor it, what's the best way to do it? Put it in descending order, right? So I know I wrote it under the plus 48, but I'm trying to put it in descending order. So that gives me x squared right there, okay? Then I have a minus 19x. And then a plus 48 because those two terms are not alike. So just tack them on the end after the x squared because, again, I want to be in descending order to make my life a little easier whenever I factor it. All right. So now step 1, is it equal to 0? Yep. Step 2, factor it. And, again, it's much easier to factor, in my opinion, in descending order. So 3 terms, the 1 in the front here. So this is a list method. We're going to say x and x. And we want 1 and 48. This is where the list method name comes from, right? One of my students called it that, and it just kind of stuck. So 1 and 48, 2 times 24, 3 times 16, 4 and 12, 6 and 8. 5 doesn't work. Neither does 7. All right. So if you get there, if you go, 3 and 16 works, you can stop. You don't have to actually list them all out. It's just a good habit to get into. All right. So 3 and 16 work here. So I'm going to put a 3 and a 16 in here. What does this tell me? The signs are the same. I know those two things are different, y'all. That's not what I'm talking about. The signs are the same, meaning this sign and this sign are going to be the same. That's the only way to get a positive 48, and they're both what? Negative. They're both negative because they're both whatever this sign is right here. So both negative. Now it's factored, right? Then the third step is to take and set each one of these factors equal to 0. And then let me make sure here that's done. Let me make sure I change to the color this time, right? The green. So then the fourth step is to solve each one of these. So we're going to add 3 to both sides. X equals 3. And then we're going to add 16 to both sides. So then x equals 3 and 16. All right? And that is solved completely there. All right? So if you watch my Solve by Factoring Basics video, many of them are already set equal to 0. And there's some that are more complicated than this to get equal to 0. But I wanted to mix it up and give you some of these, kind of ease you into this one here. 5x to the fourth. Now, we didn't see the fourth power in the other one. 5x to the fourth minus 20x squared equals 0. This is really similar to a couple of problems ago. If we look back right here, 5x squared minus 20x, I got some different powers on here. So let's look at this and see. Is it equal to 0? Well, sure, there it is, right? So step 1 is already done for us. Now step 2, factor. Step 2, factor. We're doing that in red. Is there a GCF? There's 2 terms. Sure there is. What is it? 5x squared, and then we're left with what? X squared minus 4. Am I done factoring? I might be, but I might not be. The reason I might not be is because of that 2 right there. That power's bigger than 1 inside the parentheses. That means keep trying to factor. That's what that means. Keep trying to factor. So don't forget out front the 5x squared. And it's okay, by the way, to have this squared out here. You can't do anything else with that. When you have a GCF out front, that can be -5. That negative's not in parentheses, but that's okay if it's out front. Not 5x squared minus something, but -5x squared. Okay? But it's not negative here. I'm just saying it's okay to be out there. And then here, this is 2 terms again, and it's difference of squares. You need to be able to recognize this. Subtraction, perfect squares, even powers, and perfect square number. So x and 2 and 2, one's plus, one's minus, and it's still equal to 0. And now we had a GCF followed by difference of squares. So it's completely factored, but it was a multi-step factoring. You had to factor 2 different times, actually. So not even the same kind of factoring, 2 different types of factoring on 2 different steps, multi-level. Then we come back and we say, okay, everything equal to 0. And you have 3 factors. You just set them all equal. If you had 4, but all 4 of them equal to 0. So how many ever you have, you set them equal to 0. I'm trying to change colors too soon there. All right. So then now that's done. Then the 4th step is to solve. So we're going to take this. X squared equals 0. Look, if x is raised to a power, any power equals 0, what does x have to be? The only way you can multiply something by itself over and over and over and get 0 is if it starts out to be what? 0. And then here, subtract 2. X equals -2. And then here, add 2. And x equals 2. So we get x equals 0, -2 and 2. Or we get x equals 0 and plus or minus 2. Now I want to say one thing about this in my, I think it's called solving polynomials. I'll talk about this, the multiplicity. When you have x squared equals 0, this 0 here that you get, this x is 0, that actually occurs twice. You have 4 solutions to this thing because the 4th power. It's just 2 of the solutions are 0, and you just don't repeat a real solution. You don't go, oh, I got 0 and 0. If somebody plays football and they play wide receiver and safety, you don't put them on the roster twice. They just play safety sometimes and wide receiver sometimes, but they're on the roster once. Same thing here. You just list the number 0 once, but it actually happens twice. We keep up with that at x squared equals 0, and we know it happens twice, but we only write it down once. All right. So I just want to throw that out there and say that. All right. So let's look at what we have next here. X plus 1 equals 9x to the 3rd plus 9x squared. Is it equal to 0? No. But I like to leave my highest power positive, so I'm actually going to take all of this stuff and move it this way. I'm going to subtract x, and I'm going to subtract 1. All right, now I wrote them underneath there. I could have written them out here if I wanted to or whatever, but I wrote them underneath there. Those are not like. Are any of these terms alike? No, none of those terms are alike. And over here, everything cancels, and it goes to 0. So 0 equals. Now put it in descending order. I don't care what order it's in right here. Nothing goes together. I know I wrote things above each other, but nothing is in order. If I wanted to keep it, proper, I might have said, okay, put the -x and the -1 out here and have my columns or whatever. But it's okay. What is the first term going to be? It's going to be 9x to the 3rd, and then what is my x squared term? Plus 9x squared. Then minus x minus 1. And that's descending order. And now, so is it equal to 0? So yes. So step 1, check. Step 2 is to factor. Right? The only way that we can factor with 4 terms, typically at this point, is grouping. So we want to group the first 2 terms and group the next 2 terms. I usually use lots of different colors for this, but I'm just going to keep it this way. Let me group that a little better here. That goes all the way to the squared, and then the minus goes with the x. That's the second group. So we have 0 equals, what do the first 2 terms have in common? They have 9x squared in common, and we're left with what? X plus 1. Okay? And then here, the only thing they have in common is a minus sign. Just a minus sign. So if I take a minus sign out, that changes all the signs, so the x becomes positive and the 1 becomes positive. Did grouping work? I always ask this question, did grouping work? Yes, because these 2 things are the same. How do I know I'm not done factoring? Because look, plus is in parentheses. In parentheses, there's no power bigger than 1 here, right? But wait a minute. There's a minus sign that's not in parentheses. That's how I know I'm not done factoring. Remember, I always ask you, are all your pluses and minuses in parentheses? Well, the answer here is no. So you have to keep going. 0 equals. Now this is just a GCF. This and this are the same thing. So take those things and write them out front right here. Okay? So I'm going to write the x plus 1 out front. That's my GCF, just like I took the 9x squared out or the negative out. And now open my parentheses up. If I take this out, what's left? 9x squared. So then 9x squared, and then my minus sign, bring that down. And if I take this whole thing out, what's left? Nothing. But if you factor everything out, it's like dividing. That's why we don't use the word cancel anymore in math. We lied to the math community for so long and said if you divide something, it cancels. It doesn't. It doesn't. It's not in any book now that I teach out of or that I've seen I have in my office. None. The only book that's in there is 30 years old. Okay? So if you take everything out, there's a 1 left when you're factoring because you're dividing that out. And if you divide anything by itself, you get 1. You get 1. All right, so am I done factoring? Well, all my pluses and minuses are in parentheses. There's no GCF, but wait a minute. There's a power bigger than 1 in parentheses. That tells me it may go further. And in fact, this one does go further. X plus 1, and then this is the difference of squares, right? What do you square to get 9x squared? 3x and 3x, and then 1 and 1. 1's plus and 1 is minus. So finally, after all that, had to move some stuff over, right, 2 terms over and get it equal to 0 for the purple. And then in the red, I had to group, which was a GCF, another GCF, and another GCF. That's what grouping is, 3 GCFs. And the third GCF is a group, hence the name grouping. Okay, and you group the terms together to start. That's another reason why it's called grouping. And then after you group, you have this thing here that goes into difference of squares. And this stayed out front, right? So you have all kind of stuff going on here in the first two steps to get it equal to 0 and factor. But now we're finally at that point, and after we finally get to that point, then the third step is to set everything equal to what? 0. I think I'm gonna come up here, even though I don't have a ton of space. 0 equals x plus 1, and if you wrote it, x plus 1 equals 0, it's the same thing. 0 equals 3x plus 1, or 0 equals 3x minus 1. Okay? So there's my set them all equal to 0 thing. And then finally, the last step is to do what? Solve each one of them. So I'm going to subtract 1 here and get negative 1 is equal to x. I'm going to subtract 1 here. This time I get negative 1 is equal to 3x, and I got to get rid of that 3, right? So divide both sides by it. Negative 1/3 equals x. And then over here I'm going to add 1 to both sides, and I get 1 equals 3x, and I got to divide by 3 again. So 1/3 equals x. Again, once you get to this step right here, it becomes a walk in the park, okay? So, on a nice sunshiny day with a breeze, with shade. So, x equals negative 1, negative 1/3, and 1/3. Or how could I write it? X equals negative 1 and plus or minus 1/3, okay? Negative 1 and plus or minus 1/3. And so that is now completed. Let's see what we have next here. X cubed plus 9x squared minus 10x equals 0. Is it equal to 0? Yep, it's equal to 0. There's the last thing you read, equal to 0. So that's done. Now factor it. This is not 4 terms, but it has an x to the third. It's 3 terms, but the first rule in factoring is, do they have anything in common? And they all have x. So take an x out. Anything more than x. Nope, that's it. So take an x out, I'm left with x squared plus 9x minus 10 equals 0. And now, am I done factoring? All my pluses and minuses are in parentheses, but wait a minute, I got a 2. The power's bigger than 1. That means try to go further. It doesn't guarantee it'll work, but try to go further. So, right, this is list method because this is 3 terms with a 1 in the front, okay? So then factors of 10, 1 and 10, 2 and 5. Factors of 10 that subtract to give me 9. I'm not worried about plus or minus 9. I'll figure that out in a minute. 10 minus 1 is what? 9. So that works. Now we go back to the signs. This says they're different, so I read it bigger. The bigger factor, the bigger number gets a plus. Which one's bigger? 10, so it gets the plus, okay? So we get plus 10, and they're different, so minus 1. That has nothing to do with the order up here. It's the bigger number. If I'd written 10 second, the plus would have come in the second parentheses. It's plus 10 and minus 1. Doesn't matter where you put the 10 or the 1, but the plus and the minus goes with the correct thing. So 10 goes plus, 1 gets the minus. So now it is factored completely. That was a GCF followed by list method. And then the third step is to take each one of those and set them equal to 0, right? Oops. And whether you put equal 0 on the right or left doesn't matter. It's all the same there. So, again, I'm getting a little ahead of myself there. All right, let's change the color now to solve these things, right? Because that's the last step is to solve each one of these. That one's already solved. And then we subtract 10 here, and we get x is negative 10. And we add 1 here, and we get x is equal to 1. So we have x equals 0, negative 10, and 1. And for me in my classes, I don't care what order you put those in. They can be in any order. But if your teacher says, hey, put them smallest to biggest, because that's sort of the accepted convention, but that's not right or wrong in math. Again, this is a roster of numbers, a set of numbers, so it doesn't matter what order they're in as long as there's commas between them, okay? Now, again, your teacher or your book or your software package may require the squiggly brackets. And if they do, be sure you put them in there, especially on the software package, because it'll frustrate you. You'll miss it and wonder why, okay? So let's see what we have next here. K to the fourth minus 13k squared plus 36 equals 0. Is it equal to 0? Well, yeah, I just said equals 0, right? So step 1 is done, all right? So, and what you've noticed so far, we've gotten into this one, and many of them take multiple factoring steps, right? So we're kind of expecting maybe at this point for this red to last a minute or two, all right? So let's look at this. This one's a little different. K to the fourth and k squared. There's no GCF, but there's not 4 terms. When you have powers like this, as long as the middle term, if they're in descending order, is half of the power of the first term, if the power is half, then you can do something like this. This is going to be list method, 3 terms of the 1 in the front, okay? List method, but instead of having just k in the front, you have whatever's here. So k squared. So if this was k third and k sixth, this would be k3, okay? But this is k squared and k to the fourth. So k squared and k squared equals 0. And I want the factors of 36 to add to give me 13. I'm not worried about minus right now. So I got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. I didn't have enough room. I didn't give myself enough room to list them out in one column. But anyway, there they are. Do any of those add to give me 13? 4 and 9, right? 4 and 9. And then the signs are what? Both negative. Both negative. So minus and minus. And guess what? Am I done factoring? No. And I don't know for sure just by glancing at it, but you probably recognize it already. But these twos, both of those things need to try to go further. They may not go further, but try to. And if you look at them, they're both the same thing. They're both what? Difference of squares. That's right. So k and 2, and then one's a plus and one's a minus. That's this one right here, right? And then this one goes into those two, and it's also difference of squares. It becomes k and 3 and k and 3, okay? So be careful. We talked about upper and lowercase letters in other videos and things. Make sure that, this is a capital K, no matter how big or small you write it, and this is a little k, right, where this, is taller, much taller. So if you write it beside something, this is obviously a capital K. I don't care how big you make that. So 3 and then little k, right? So, but K is shaped the same, so it's a little, well, sort of. All right. So then here, one's plus, one's minus on the 3s over here. Oh, wait a minute. So let's go ahead and kept that on there. So plus and minus. All right, so that is now factored completely. And then the third step is to take each one of these and set it equal to what? 0. So there's 4 of them this time. So k plus 2 equals 0, or k minus 2 equals 0, or k plus 3 equals 0, or k minus 3 equals 0. Right? Doesn't matter if you have 2 factors, 4 factors, 3 factors, 57 factors, you set them all equal to 0. And then the fourth and final step is to do what? Solve each one of them. So minus 2 here, we're going to add 2 to both sides, and k is plus 2 or positive 2. And then subtract 3 from both sides here. K is negative 3, and then add 3 to both sides. So we get k equals negative 2, 2, negative 3, and 3. And you by now know I would never write it that way. For me, I would accept it from you that way. All right, k, or from any student, plus or minus 2, comma, plus or minus 3. So I'm only writing the actual numeral of the 2 and the numeral of the 3 once each. So there is that one solved out. So one of my oldest favoritist, I know that's not really a word, so all you English people don't get mad at me. That's my favoritist one of these, all right? So because you factor it, the list method with k squareds, and then each one of those things becomes difference of squares. So this thing goes into this, and then it branches out here and here, okay? Oops. All right, so that is solved by factoring more. I hope it helps you out when you are solving by factoring.